Good morning, students. Today we will learn about Maxwell's equation for scalar and vector potential. So, to solve this, we are using Maxwell's first order differential equations. And we need this Maxwell's equation to write the scalar and vector potential form. So, here we'll use scalar potential as phi and vector potential as A. So, you already know Maxwell's field equations, that is divergence of D equal to rho and then divergence of B equal to 0 and then curl of E equal to minus del by del T of B and then curl of H equal to J plus del by del T of D. These are the Maxwell's field equations. So we'll call these equations as equation number 1, A, B, C, D. So now according to equation number 1b, we'll just take equation number 1b. We'll take equation number 1b. Which is that equation number 1b? Divergence of b equal to 0. And we know that, what is that? Divergence of curl of any vector is always 0. B can be expressed as curl of A. We see how we can express this. See, we have divergence of B equal to 0 and divergence of curl of A equal to 0. So, we'll equate both of these equations. That is, divergence of B equal to divergence of curl of A. So, divergence and divergence cancel out and then B equal to curl of A. So, we substituted here, that is B equal to curl of A. This A we call it as vector potential. Then we'll move on to, now we'll take Maxwell's equation third, that is 1c. Third equation we'll take 1c, that is curl of E equal to minus del by del T of B. In place of B, just now we got B equal to curl of A. From first equation, we'll substitute that. That is minus del by del T of curl of A. And then we'll take it curl out. So curl of E plus del by del T of A equal to 0. As we know that curl of gradient of any scalar function is always 0. We'll check for these equations. That is curl of E plus del by del T of A equal to 0. So now that is curl of gradient of phi equal to 0. So we'll just equate these two equations, that is curl of E plus del by del T of A equal to curl of gradient of phi. So curl get cancels, that is E plus del A by del T equal to gradient of phi. You already know what is that? Any gradient of scalar function is negative. That is scalar function will always express in negative. So E plus del by del T of A equal to minus grad phi. So we have substituted in this, that is E plus del by del T of A equal to minus grad phi. We'll call this equation as equation number 3. You got equation number 2, you got equation number 3 by using what? Maxwell's second and third equations. Now we are going to use Maxwell's fourth equation, that is 1D, equation number 1D, which is that curl of H equal to J plus del by del T of D. In terms of B, you already know this, B equal to mu H and D equal to epsilon naught E. So we'll use these conditions. You already use these equations in what? Maxwell's equation while deriving Maxwell's equations. So we'll use this in this Maxwell's fourth equation, that is curl of B. Check this, B equal to mu H. So H becomes what? H equal to B by mu. So in place of H, I am going to substitute B by mu. So that mu goes to right side and multiply with those terms. So that is curl of B equal to mu J plus mu epsilon del by del T of E. So this equation, we'll call it as equation number 4. Now we'll use equation 2 and 3. Which is that equation 2? Equation 2 is, you can check. Equation 2 is what? B equal to curl of A is the equation number 2. And then equation number 3 is what? E plus del by del T of A equal to minus grad phi. So these equations now we'll use here. So what happens when we use these equations? Check in this right side. That is, this I just modified this equations. That is E equal to minus del A by del T minus grad phi. So this, in place of E, I'm just substituting this one, and in place of B, I'm substituting curl of A. So that is from equation 2 and 3. So in this side, that is curl of B place, I'm substituting equation number C. In place of B, I'm substituting curl A and mu J as it is, and then mu epsilon del by del T of, in place of E, minus del by del T of A minus grad phi. So now we'll just this curl of curl A. What is curl of curl A? Curl A? The formula. You already know this formula. That is curl of curl A equal to gradient of divergence of A minus del square A. That is, when gradient curl of curl A equal to gradient of divergence of A minus del square A, and then equal to mu J, then minus mu epsilon del square A by del T square. We are just simplifying this. We're just multiplying, and then mu E del by del T of grad phi. So now again we'll just simplify this equation. That is, gradient of divergence of A is del square A minus this del square A, and then mu E del square A by del T square, and then minus gradient, I am taking it out, and then divergence of A plus mu del mu epsilon del by del T of phi, that is equal to minus mu J. I have just shifted this mu J to this side and del square A to this side. So this equation, the equation number, we'll call this equation as equation number 5. This equation, we call it as Maxwell's equations for scalar and vector potential. We got the equation, first equation for Maxwell, that is for scalar and vector potential. There is also one more equation for scalar and vector potential. So to solve that, we have left out with one more Maxwell's equation, right? So we need to take that also. So take that equation, which is that 1A. So 1A, Maxwell's first equations we have left out. Through that, we'll get one more equation for scalar and vector potential. So equation number 1A in terms of E. What is that? Divergence of E equal to rho by epsilon. So we'll just use equation number 3. What is that? E. Equation number 3. In that E, we'll just substitute that E value here. What is that? Divergence of E. In place of E, minus del by del T of A minus grad phi equal to rho by epsilon. Now that is divergence of, we'll just multiply minus sign from both the sides. We'll just multiply minus sign both the sides. What happens? Divergence, that is minus grad phi, becomes plus, that is divergence grad phi, and then plus del by del T of divergence of A equal to minus rho by epsilon. Now, next what we'll do? We'll add and subtract both the subtract in this equation by what? Mu epsilon del square by del t square of phi. What we get? Del square phi minus mu epsilon del square phi by del t square. Here we have subtracted. Then plus del by del t of divergence of A plus mu epsilon del square by del t square phi. Here we have added. So that is equal to minus rho by epsilon. This side we have subtracted and this side we have added this term in this equation. So this equation we'll call it as equation number 6. So equation number 5 and equation number 6 are the Maxwell's equation for scalar and vector potential. So first fifth equation is the first equation for scalar and vector potential. Equation number 6 is the second equation for Maxwell's equation for scalar and vector potential.